Hello, hello.
Hello, it's okay.
Hi, Neil. Hi, Tanya. Hi, Matteo. And hello, SG.
Good afternoon.
Hey, Matteo, which company you are with?
I am with Infineon Technologies, working on
Ah,
solid state circuit breakers and solid state protection, power distribution protection components and systems.
interesting. Thank you.
You're welcome. And yourself?
Yeah, Anil Agarwal, I'm part of Meta.
How? Very good.
Hi, good afternoon, all. I see a lot of emails like people not able to make it today. Maybe less attendance.
How about Drew?
Drew is also off. I think Drew, Vilas, and there's a few other people.
Okay, we have
It,
8
uh,
people here. So you want to take a look at uh, some of the scenarios that we started discussing? Or should we use
yeah,
this time for just general sync alignment plan for the year?
maybe we can use the scenarios, maybe planning, maybe if more people are there, maybe that's better, right?
Sure.
Was there a meeting last week?
No, I think
I don't think so.
no. Like you want to share, Anil?
Yeah, I can share. Since Revelation, is that you?
It's a different meeting room, Anil. This is Meeta.
Yeah, this is Mita. So since you are here, am I sharing?
Yeah,
Yep.
yeah, you can see.
Okay. So in the scenarios, we have this PCIe advised non-fatal that I think we put some efforts and then have not discussed after a while. So Mita, since you are here, should we?
I don't think I'm ready to discuss it today, but I can in a in a future one there where we planned it.
So I did edit that, and I think you added some comments after that. So there quite a bit of good stuff is added there since the
Yeah,
first discussion.
if we can like hold this for a future one where it's on the like a little bit on the calendar, I would prefer that. I'm just like a little brain dead today from the kind of day I've had.
Ah, okay. I mean, I don't mind sharing. I mean, discussing the section that I added, or if you really suggest to defer it, that's okay. Any other scenario here? Maybe see. I think this is do stuff. I mean, I can talk about any of these
We can go
scenarios.
through the first like oral summary, what are the things we plan to cover, and then
Is this the one?
yeah.
Error containment, memory error handling scenarios. And then PCI scenarios. Let's see what else. Special cases error logging. Sandbox. PCI error handling end-to-end code. Okay. Yeah. So I think let's see. There is a overall error containment kind of area, which is a pretty big area because it cut across memory, PCIe, any kind of high-speed links, device to device. Again, we are not especially talking about GPU here, but we can call it in general generic. How do we achieve the containment when we are in a cluster environment? Let's put this with a scale up and scale out. Memory error handling is a big one. And also memory errors at runtime leading to PPR. Is that someone Drew did? Yeah, this is the thing. Drew and Mita, you are also here. Oh, there are a bunch of other folks. Maybe we might have already discussed this. Then boot time PPR. This is a good one. And there's a lot of proprietary kind of implementation. If we can come up with a flow that becomes like a template to implement in the future products in a more similar way, then it'll be good.
That in that case, like we need to consider the thresholds. Those may be customized based on the fleet size, learnings, right? But how do we invoke? When do you invoke those
Yeah,
things?
I think that's
Yeah.
what, right? How do we invoke?
Yeah.
And then what kind of error reporting? So when boot time PPR is used, it may not be successful all the time, right?
Yeah.
Or it may be successful. So if it's successful, how do we know? Because it's a boot time, right? So we need to define some ways to report boot time errors. Out of band and in band.
Currently, okay. Yeah. I just wanted to mention that currently there are ACPI methods to report boot time PPR.
You share more details?
No, I don't think so.
Yeah.
Which one?
So
Okay.
there's a ACPI BDAT table.
BDAT table. Yes.
Yeah,
So
and that has all. Yeah.
BDAT table will have a memory training kind of information.
No, they added actually a lot of
They
stuff,
have,
Rama.
yeah,
Oh.
EWL headers, which will tell you if PPR happened, if it was successful, which row, column, not column, but like which row, bank group, all that stuff, whether rank, unmap, all that stuff's in there.
Yeah, it's
there are some
modified on today. So 1st Jan.
Sorry, say that again.
Analysis like done, but
Didn't catch that.
Was that Ankit?
Is it Shubhada or?
No, not me.
Oh, okay.
I think I saw Ankit Saxena speaking that time.
Oh, maybe background noise, maybe. Go ahead, Mita. Yeah, thank you. Yeah, like I checked it only 2 years back, maybe.
Yeah, so
no.
it's there. I mean, how full featured it is, we can probably look at, but it exists and it has signatures for whether PPR has occurred, where it's occurred, which DIMM it's occurred on. If like PPR was not successful, things like that are there in it.
Yeah, but one thing is that standardized, right? I think it is vendor specific information currently in the EWL because
yes.
Yeah.
But BDAT itself is ACPI.
Yeah, but you can put anything in those buffers and provide the interpretation. So it's not really standardized, but it is using standardized mechanism to put
Yeah.
vendor specific information.
Yeah. Yeah.
Yeah, so there are a few other things here. First of all, even though BDAT spec is out in public, right? In the as a UEFI portal on the UEFI EMTF, the way the spec is written, right? They've kind of created different profiles, and it's really an implementation choice. So it is there in the spec, but at the same time, the implementation may vary depending upon which profile is implemented. So it gets very tricky to say, hey, if you use BDAT, if you implement BDAT, we will have support for boot time PPR reporting. So it's not that straightforward. If you look at here, right? I think I'm still sharing, right?
Yeah. I think the
Yeah.
spec you opened is a very old one, I think.
Huh?
2000.
I don't think any changes are done for a long time. This is I just pulled out from the spec. I'm from the Google search. So
Oh.
if there's a new one, then I can take a look at that also. But
Yeah, I agree with you, Anil, that if it was more standardized, I think it would be more useful to all of us. I totally agree with that.
yeah, so this is it, right? Memory data schema 2. So in this schema, basically it was all the training information as I was mentioning. Then what they did was they introduced, let's see, this is all, yeah. Yeah. Then schema 2B, then they added some more stuff. I think cleaned up training structures, training data, and that. No, I think there's some information. Schema 4. I think there's one schema where there is a BDAT table. Sorry, additional EWL stuff. Let me just search for.
I think the challenge we face when we try to productize this, right? This is like early drafts and all the data, like how do we analyze it? Productization, I think the maturity is not there, I think.
Mhm.
Yeah.
Yeah, so this EWL, by the way, is very one vendor specific. This cannot be scaled to other vendors, right? So we need to define something which is vendor agnostic. And I think EWL doesn't
Maybe we
have
should work with the UEFI and team and understand like what is their plans. Maybe then we can leverage it, right? Instead.
Yeah. So we started deploying BDAT now. The only problem is it doesn't have much information, useful information, right? For us to make use of it.
You cannot drive the decisions. Oh, it's coming from fully.
Yeah.
It helps a little bit. Yeah, not. Yeah.
Let's see if I can find PPR, right? PPR. No, I don't think PPR is added here. Mita, is that version that?
So the EWL EWL specification is a different one, which this spec references it, but like you said, it's a vendor specific, right? So there is another doc which spells out the fields in the EWL. This one just has the types, I guess.
I see. So yeah, so this becomes vendor specific then, right? So either we.
No, actually, this is it. What you just had there, the major warning code, minor warning code. It says Appendix A. Yeah, maybe you'll find it there actually.
Appendix A.
Yeah, if you go there,
this is it.
oh, okay. Well, yeah, then there's another document which has these. It looks like a lot of stuff is here though.
So there's a DPA, PDA stuff here, which is type. It's like EW entry type 77, timestamp, host sequence, that's type 27.
Can you search for type type 4.
Type 4.
Yeah. Type 4 or type 5. 4, 5, I think is good. Okay,
Signal
5.
training data.
5.
And then that's it.
Oh,
5. Oh, 5 is there, sorry. IO
oh,
latency.
no, this is not what I was thinking about. That's okay, but I think like having it standardized will obviously be helpful to all of us.
Yeah. By the way, talking about this beta, beta actually is a very, very useful table. The one scenario which is not listed here is how do we get the SPD data from the DIM? Today, there is no standard method defined at a fleet level. Okay. I mean, it's
Just
a
to
very
read
platform.
I2C commands, right? In general.
Yeah, no, I2C command is the way you read the SPD, right? But it's a very platform agnostic,
Yeah.
sorry, platform specific implementation, right? At the fleet level, what kind of protocol, I mean, is there any API defined? Has anybody defined as part of a generic command interface, regardless of platform specific, like for example, redfish method, right? You do a query, get me the SPD. I don't know if it exists today or not. And if not, should we do that?
Yeah.
Because SPD actually has a lot of good, useful information. Even this bounded fault. By the way, I didn't know. I learned fairly recently that DDR5 already has a bounded fault implementation, and some of the vendors actually use it today. Some of the SoC vendors. But at the hyperscale level, we don't know that because we have not been monitoring SPD at all.
Yeah. That is good. Yeah.
And
what do you
there's a
mean
date code.
by
Way we could
what do you
do
mean by
this is
using bounded fault, Adil?
Yeah. So remember, I was talking about, Mita, if you join early. Oh, sorry, it was a different meeting. My bad. Okay. So let me, So the bounded fault is a concept where, especially, it is useful in the by 8 DIMMs, where based on the DRAM fault profile, like is a sub-word line driver or word line failure, the way the data is pushed, the prefetch data is pushed to on the pins that controller reads it. DRAM vendors has a choice to remap that and put it into the defined zones of all the data DQ, bus length, basically the whole data pattern, in such a way that controller will know, okay, for a given kind of fault, this is where all the bits, the faulty bits will be located. And the controller then can, and this all has to happen negotiable boot time, can restructure their ECC code to make sure that they are all fall into the ECC code coverage. So using bounded fault concept, the code coverage, ECC code coverage can be significantly improved, where uncorrected errors will turn into correctable errors. And this becomes very, very important. And actually, not just uncorrected error, but also silent errors can become either uncorrected or basically detected errors. So bounded fault concept.
Yeah, go ahead.
No, yeah, that's it. Yeah, go ahead.
So my understanding was by 4 DDR5 DIMMs do have bounded fault, right? And you're saying that we don't have it on by 8. Is that the thrust?
Yeah. So in the case of by 4, since we get the whole full chip kill, therefore bounded fault is less interesting. For silent error, it is still important, but from a uncorrected to corrected mapping is not that interesting. In the by 8, if it's a one row failure, it becomes an uncorrected error. But if it's a one row failure, actually is like a subword line failure, DRAM vendors have a choice to map it to a column.
Now, when you say
Co-
map it to a column, tries to map it to a column, is that something that's done dynamically? How
Yeah,
does that work?
yeah. So typically when you make a request to the DRAM, right? So DRAM will take that read request, pull the data out from the mat, put it into a buffer,
Mhm.
temporary buffer, and then push it to the driver, to the whatever the IOs. So during that, they have a choice to remap the bit pattern or bits, rearrange the bits. And so they can make sure that if it's a subword line failure, it will either map into if you picture the DQ and the burst, like a
Mhm.
two-dimensional matrix, they will appear like a DQ failure or a kind
Nice.
of row failure, 2 rows or 3 rows, depending on. So basically, they can remap the faulty bits into a specific zone, a specific bit patterns, which would then map into the ECC code.
And this happens dynamically at
Uh,
data access time.
Dynamic. So DRAM read data patching from the mat to the actual buffers is all dynamic, and the rearranging also. They do it for various other reasons. But the bounded fault is decided in the boot time based on the manufacturing and the architecture and design of the DRAM. They will say, okay, if I see a subline failure,
Yeah.
I'm going to map it to a DQ only. Okay, so I will ensure that all subline failures map it to DQ, and they will communicate through SPD. So controller knows, hey, as long as my one DQ coverage is there, subline failure is taken care of. They will all be correctable.
Yeah, and there are,
I
I
see.
guess, just to clarify a little bit, Anil,
Oh
there are
yeah,
a lot
you're there, so you can
of.
explain better.
I mean, I largely agree with what you're saying. There's a lot of design implementation decisions that go into that too, kind of on a per design basis, as far as what maps where. But in general, yeah, that's correct. There are some decisions to be made about what maps where in terms of correctability, especially on by 8, since
Right.
you can't get everything.
So SPD is becoming very useful, by the way. And reading that and collecting the data at the fleet level is extremely useful. But today, the problem is there's no standard method. And the reason I'm bringing that here is because BDAT table, the way the specific vendor who's developed the spec, actually I can call because I think it should be clear here. BDAT table is the publisher name is already listed here. Okay, because I was part of the team who pushed it in this spec. I mean, it came from Intel. Doesn't say. It probably stays somewhere in the UFI spec portal. Who sort of published it? So in the BDAT table specification, there is a SPD data type structure also defined, but it's not very well articulated in the spec, and I don't think anybody has uniformly implemented. But it is possible because BDAT actually table exists today, and can be. So we can make a better use of BDAT table basically. That's something by refining the spec and then enforcing through hyperscalers to the vendors to implement it in the BIOS. And the benefit.
Question, Anil and others, right? By going through these scenarios, we want to see the gaps where the standardization and update the hardware fault management or some other industry standard spec. Is that
Correct.
the idea, right?
Yes. By defining this boot time PPR flow as a scenario,
Yes.
we want to at least define one type of flow, and in order to implement such flow, what all areas require standardization is required.
Yeah, what is currently implemented in the industry?
Yeah.
standardization and what are the gaps and influence either that particular forum or as a OCP we do it.
Correct. So one method is sort of BDAD, right? Which is because any machine, right, has to boot, and the boot time firmware is the one that goes through the whole initialization. So generating a BDAD is going to be very sort of common implementation across all the CPU vendors and CXL controllers, wherever the memory is used. Other method is out of band, like through BMC, accessing I2C to the DIMM. Now, that is also feasible, but the implementation, the access to the I2C through BMC may not be available all the time in all the designs. So using that out-of-band method may be not really scalable. And maybe in this scenario document, we can define different possibilities and different trade-offs. Ultimately, what we want to define here is, okay, what should be our method to collect this information, boot time PPR, the SPD information from a platform agnostic method for the hyperscalers. So in band, out of band, there are two approaches. If it is out of band, Redfish. In band, if this BDAD table can be pulled out and can be pushed to our infrastructure and schema defined to decode it, implemented it just like a libcper. Actually, BDAD table kind of appears like a CPR type of structure, binary structure. So just like any other ACPI table. So writing a code for that and then pushing out, upstreaming it. As long as we can put the timeline of implementing those part of the implementation, then boot time PPR adoption will become much easier.
Yeah, and then we are finalizing certain contents of the SPD or certain things like the secure ID or a manufacturing user ID, which 64-byte IDs with the various fields which get written into the SPD or in the OTP or secure refuse. So that we are finalizing as part of certain specification in the JDEC task groups. So if we have certain requirements over there for like the you said for SPD or for PPR or these BDAD tables, then we should be able to specify them, and then we could have them added in those JDEC specs too, where various memory vendors are also there, and we could have it in those specs, and then it'll get absorbed into the products.
So that's the interesting one you mentioned. So I think what you're saying, Sakul, is that when the platform takes a PPR action, boot time, then if platform can push it to SPD, saves into the OEM specific field of the SPD, then that information stays with the DIMM, even if you move around the DIMM, because PPR actually is very DRAM specific function. Right. And if it stays with the DIMM, that's better. Because if you move around the DIMM, right, the row repair information stays with the DIMM. But today there is nothing defined there's no spec defined to save that data structure into SPD.
Right.
We have done our own implementation. I'm sure other players have done their own implementation. So that's another area to explore, where the PPR, if the PPR is successful, okay. Now, if the PPR is not successful, so we still need a platform method when somebody is implementing and deploying boot time PPR. We still need a method to report the PPR related information, either successful or failure, from the platform to the hyperscale, to the infrastructure. So that will still be required. But then let's say if we're successful, if you can push it to SPD, so that in the next boot, so it's become more of an implementation kind of, streamlining. During the next boot, the firmware can then read the SPD, which it typically does, to know what all the previous entries are there, and then new entries. If they're different, then update further. If same entry, then you don't have to do again because it's already PPR. So that's more of a implementation. But saving the information SPD actually is a very good one. Yeah.
Yeah.
I have a
Persistently.
question. Go ahead.
No,
Go
yeah,
ahead.
that's it.
Okay. So I have a basic question actually. We were talking about failure, error injection and stuff last week, right? So I just want to connect the dots between this memory handling, the PPR stuff, back to the error injection. Are we saying that we inject an error into this like boot
No,
sequence
no.
or a boot
This week,
memory, or what about? So I am trying to connect the dots. Could you please explain, please?
This is a
Clarify.
separate topic because some of the team members are not there. Last week discussed on memory. We started like going through scenarios. Those are not related.
They are not related. Okay, thank you. Sorry.
Yeah.
Yeah. Sorry. Right now we are just taking this time liberty because not a lot of people are here to kind of more of a, how do I say?
Continue the discussion on error injection. Like we thought we'll do it next week. We'll just
Okay.
there are other
Yeah. So
topics.
yeah, but if that's even if you just say about this, like memory errors, right? This is handled today anyway, right? Isn't it? I mean, it's not new. So we have memory failures with whether it's boot time or not boot time, anytime. Like even if you're running an application, it's possible that the memory will have a hard failure or soft failure, whichever way they calculate. I mean, assuming like we care more about the hard errors and we need to repair it. So hardware vendors already have schemes. I mean, especially if it is Intel, like we have schemes, right? How to fix it on the next boot, or to take that line out of commission when we come back. And if obviously assuming that it was repaired or there is a spare line, that's being handled today seamlessly. So why do we need to give extra attention through CSP flows?
That's a very good question. So let's say a row failure is detected, runtime, right? And the post-package repair is requested during next boot. Okay, it's all platform specific. And in the next boot, let's say attempt is made, but it fails. PPR is not successful. Either spare row is not available or for various other reasons. What platform does today is very platform specific way. It just continue booting. There is no error information is reported. Or even if there is error information reported, the hey, PPR failed, it's not very standard way, means platform agnostic. So now hyperscalers have to figure out, work with vendors, implement some additional error schemas when PPR fails or PPR successful. Even PPR successful also, it's important to monitor. Just because PPR is successful, if we don't know, maybe three is PPR already successful, and now the DIMM is compromised, means it's already at the verge of failing, becoming basically not very good, not so good kind of concept, right? Degraded. If you don't know it, suddenly the DIMM fails, machine crashes, application interruption happens. That's bad for us. So we need to know a priori. Hey, there was a failure, corrected, not corrected. How many failures have happened so far? If you don't have the information, we are completely blind. So monitoring
I
those.
think these are two different things in my opinion. So one is like at the boot time, and second is during application time. During boot time, if there is a failure and the PPR was not successful, I think we should check. I'm pretty sure like each vendor will have a status register which would say like PPR successful or not successful. It may not be getting reported to the CSPR or it is not being read in a systematic way. Probably, I think it would be just easier if if we just say each vendor please report and like this is the standard register we will be reading or like whichever command,
Exactly.
right?
This is
So just
this is all we are looking for.
okay, yeah,
How
I
can we
think
implement in more standard way? Either push it to SPD and then pull it out from SPD through BDAT table and then
got
read the
it.
BDAT
Yeah.
table, right? That's exactly what we are looking for. We are not looking for
Okay.
the actual PPR implementation itself.
Okay. Yeah, and that should be straightforward for vendors. Like if it is placed as a requirement in the spec, right? Then they can follow. It's just exposing that status.
But which spec? Right?
Yeah,
There's no spec as such.
sorry, I think in SMBIOS there is some information about the SPD information, like SPD data.
Some data, not
not like extensive data. Yeah.
Yeah.
So,
what we are discussing here doesn't exist anywhere. So someone has to take few steps to define that, decide which spec, what are different ways to implement it. So I think OCP is the right forum to kind of define this framework of the problem statement and what are different possible scenarios, possible ways to implement. And based on each scenario, drive that requirement to the spec. So it could be through SMBIOS table, could be through BDAT table, ACPI spec, UEFI, through UEFI. I think SMBIOS is not part of UEFI, right?
Yeah, it's a DMTF or something.
DMTF, yeah. No, but UEFI also, UEFI is, no, actually UEFI also rolled into DMTF now. So I think parent organization is still same, but then people working on maybe different. So yeah, I mean, there are different few other options to define in a more uniform way. And of course, eventually when we get our RAS APIs defined and implemented, we will have that. But until then,
one comment there, Anil, is that the pipe to collect it would be RAS API, right? Like if you do like get config or some kind of command which gives you the information about the configuration, that will send you back the whatever you ask for, right? Like whatever features are supported. But the format is what we are talking about here, right? We need to have a format defined that can go over the given pipe. I think it's not too far, right? Like you can use BDAT, but we can standardize the format of the data that we want to send, and that can then currently it can take ACPI table as one of the path, or in future it will use RAS API.
Yeah.
Sorry, I was gone for some time because I had to step out to pick up kids, but I wanted to make a RAS API point that we will use that as something to collect the information or topology or any features that SOC supports.
Yeah, I think in the PPR RAS action data structure, like there'll be CPR and there's CPAT. There'll be data structure need to define for PPR.
No, I mean, this is not CPR CPAT, right? This is configuration, like when we have the get config from a RAS API endpoint, that command response should return you the feature that you're requesting information about, right? Like, so get config about scrubbing, get config about SPD, get config about mem topology. Those commands are the ones which will return this data. It's like more like configuration and feature support commands. And CPR and CPAD are about runtime actions and events, right?
Mm-hmm. Yeah. So what you are saying is that Whether a platform support PPR or not, that information will be as part of the query, the initial query that we're defining in RAS API. And if the PPR is supported, what type of PPR, boot time, runtime, hard PPR, soft PPR, MPPR, that we need to define that structure fields
Correct.
which
Yeah.
will roll into API.
Right. Yeah.
Yeah. So that's one part of the equation that we need to define for RAS API next level details. Other part here, what we started discussing in the beginning was the boot time PPR already implemented today, but it's a platform specific. So from a hyperscaler fleet, if you want to do today, it's like a low-hanging fruit. It is already there today in our fleet, right? But we have to struggle to implement vendor in a vendor specific way. And even within one single vendor from platform to platform, we have to keep hand tweaking it. So it is becoming very difficult for us to deploy such feature. In fact, we get a lot of pushback because the trust is not there. Because the moment they see there's a different implementation in two different platforms, they say, "Hey, what's going on here? I don't understand." If we can implement in a way that from a fleet level, we have single API, single type of data structure we get, and somebody can test it independently. I mean, I can test it on every platform because I know the implementation, but if I have to give to somebody else, right, they can just pretty much run the same API, same command, and then test it, no matter which platform it is.
Yeah,
Now
same
the trust
problem we
better.
see. Yeah, same problem we see. Like
Yeah.
each
So
silicon.
we need to solve that problem, right? Of course, RAS API will eventually solve that, but that's still, we are talking about a year, 2 years down the road. What can we do between now and let's say 2027? Can we do something at the low-hanging fruit and define something that can be implemented in platform that are being developed this year and next year?
Maybe other way is Anil,
What
like
part of
maybe accelerate the RAS API thing than coming up with the new, right? Because if it's only short term, I think by the time we release the spec, people implementing, anyhow, it is going to take 1 to 2 years, I think. Yeah.
Actually, I would say other way around, Rama. So RAS API, let's say it takes another year to actually release the spec. Then it will take another 2 years, 3 years before it becomes mature for our fleet guys to really trust RAS API. So I'm talking about RAS API based platform in our fleet, which they can actually trust it. We are talking about 3 to 4 years, 3 to 5 years down the road.
Yeah. Okay.
Right? So no matter how much we push or how much we rush or speed up, the reality is it takes time. Right? And PPR is being used today. It is so effective today for us. It's just that our fleet guys are so hesitant to test it out, and there's always this pushback. So if you can solve that problem based on the specs already exist today, just hand tweaking it, modifying it slightly here and there, I think that still has a lot of value through our OCP initiatives. We can call it a bridge to RAS API. The RAS API, even if let's say we have perfect solution today, nobody will deploy it until they test it out in different scenarios. And the testing itself will take time. It's not going to happen overnight. And it will be only the new platform, right? So what about the existing platform? There's always a challenge when we have to completely overhaul something, right? How do you launch it? How do you intercept it? Because now you already have a current fleet, and now you have a new fleet with a new implementation. So our tooling has to now support two different implementation. To deploy that, it takes years.
Yeah,
I'm not kidding.
Yeah. I know.
So it's a naive to think that, oh, RAS API we can speed up and we'll get in next year. No.
To switch to UEFI boot mode itself, it took like 3-4 years. Yeah. from legacy?
Yeah, let me give you a real thing. CPR implementation, we started talking CPR a lot now, right? And a lot of platforms now are implementing and we're deploying the fleet. Our tooling, at least I would say, if not 2 years, at least 1 more year before we can actually start consuming it. Because we already have the whole infrastructure today. Changing that infrastructure to switch to CPR is a nightmare.
And then
We just
accounting for some of the differences with vendors, for vendor specific CPRs and all too adds to the complexity as well.
Yeah, and that actually become more. So now the one sort of pushback we get here is, oh, CPR is making my life more complex. I had a simple 16-byte cell log, and now I have to deal with this much bigger data structure, and it is not the standard. Every vendor has their own CPRs. So what standard you are doing here?
Somebody asked to convert the CPR to cell equivalent. Give me the wrapper.
Oh yeah, we did that also. By the way, in some platform we were forced to do that because anyway. So the key point is incrementally, if you can improve it, that we can ingest, always sticks, and easy to intercept. That doesn't mean that we should not work on RSPI. We definitely have to work on and get it, get the spec out, so that at some point in time we will start getting more.
I think
RAS API
0.9 is released, right? 0.9 is close to release, I think. Yeah. There's more work to be done, I agree.
Yeah. So this year, let's shoot our target for RAS API 1.0, which can be implemented, right? And then the next year's platforms will start implementing it, and we'll start getting it in our fleet. Some of those platforms that we can then do hack. We'll be able to go through hack to convince ourselves, yeah, RAS API is going to help us, and so and so. So it at least, even let's say we get 1.0 this year, it'll take us 2 years from now, actually 3 years, to start seeing some deployment in our fleet. And by the time it becomes mature, it'll take years. It's not going to be that easy. And we all have to put a lot of effort, actually. It's not going to happen. It's sweat. Hard work and sweat, right? We have to convince every, so many standing committees and so many places to align. Because when we define something, it'll break something else. Or it kind of conflict with some other spec, some other implementation. So we need to work through all those details.
Hey, Anil, from your previous comment, are you saying that you prefer, even for CPRs, like as much standardization as possible, and same on CPADs? Or because I mean, we have a little bit of a contradictory requirement here, right? Like some are really in the camp of non-standardization of the CPR records, like Drew has said that multiple times. He's not here today, but that's his position, that vendor specific data is richest, right? As long as they analyze it and provide us output. But and that's why even in RAS API we are not defining a standardized CPAD section body, right? So I mean,
I think Shraddha, as long as silicon vendors give the analyzer tool, okay, because they have a IP restrictions, right? Like headers and all top content is standard, but section specific, like it depends on the silicon vendor, right? Sometimes they don't want to reveal their IP.
Oh, definitely, yeah.
But they want to give the analyzer tool so that like the summaries are actionable, right?
Right. But I mean, there are sometimes, having that structure also helps vendors because, there is always, if you look at UEFI, right, there is always a generic structure and then there is, modified versions of it, right? Like there is, even for a CPR, like there is a generic guidance on what could be there, and then you can append with like some kind of vendor specific data. So I mean, does that kind help, especially for CPAD? And wondering, I mean that
yeah, in my opinion, Shubhada, sorry to interrupt you. I think I got your point. For CPAD, I would like to see at least one or two standard formats, or one or two error types, or sorry, action types, or maybe a handful of very common action types defined somewhere in the spec, which is implemented uniformly, and our tooling can implement it without any vendor specific content, and then define in such a way that there is a vendor specific way to implement all other additional.
Yeah, I
Just
mean,
like
we
a
will
C
discuss
program.
this in RAS API meeting.
Yeah.
I just wanted to
Yeah,
get your
I
view
didn't. Yeah,
on this.
yeah. I haven't pushed that yet in our CPI. I mean, sorry, RAS API discussions, because I want to at least get something out, right? And I know we are not defining anything standard format for CPAD and just leaving it up to the vendors. It is going to be even more challenging. It's a how do I say? Is a problem in either way, because if we make it vendor specific, now vendors are going to say, okay, I'm going to, even if I give the code, I'm not going to upstream it. And in our tooling, it's a no-go. We want to implement vendor specific code only if it is completely legally indemnified and whatever that we call, like completely open source and available without any legal foundation.
Which
And
analyzer tool or?
Yeah, and decoder, analyzer, basically, yeah, decoder, analyzer, and
decoder will not be, right? I mean, so there are some, if there is a vendor specific.
Decoder also has to be vendor specific, right?
Right, yeah.
Yeah, so decoder is vendor specific, analyzer vendor specific, and if vendors cannot share that code in open source, so if they share in open source, that means there's no specific IP there, then you might as well just push it as part of the spec. So I'm not saying everything has to be part of spec and vendor have to disclose everything, right? That's also not going to fly. So we need some balance here, where some basic things are.
Like why they have to open source the vendor code? Why can't they like work with individual CSPs, hyperscalers to license that?
Then who's going to maintain it? And when there is a change, what happens then? We need to have our own team members working with every vendor to keep track of, okay, vendor has now released the next version. Let's go and integrate it, right? There's no automation. We want automation.
But I mean, like say you have a firmware update today, right? Like say we changed something in our algorithm in doing SPPR in BIOS today, right? SMM. You have to go and update the firmware on all of your nodes. Whereas if that logic was as part of the analyzer, then it's only when we provide you the analyzer, you will just go and update your analyzer, and that's all you update, right? So you don't have to deploy the firmware update on all of your fleet, whereas you just you just have one component in your architecture, yes, but you end up changing it in one place and you have it, right? So that's the benefit of all that we are doing today, that you have a standard pipe plus you have an analyzer which is sitting outside of the fleet, right? Like it's in your management software, and that's the benefit that you get.
Well, so that's a different thing, right? We don't mandate that analyzer has to be always outside. Although we've been drawing pictures showing outside, but it could be on the platform, it could be on a BMC or on WAN, right? That's a different discussion. The point is that whatever analyzer code, okay, either we have our own team who is always monitoring each and every vendor's code releases and ensuring that it's integrated into our fleet, regularly. So maintaining the fleet in an automated way, where a simple rule, okay, every week go and fetch from the open source tree, just like a Linux. Think about a Linux kernel, right? Linux kernel, there's a kernel version, and when we want to fetch a new version, any patches and everything is all integrated together, and we just pull out one tree and build it and deploy it.
I
So overnight
think,
we can deploy.
Anil, that is a good feedback. I think industry is not even at phase one level. Like they're talking about phase two, where phase one is they're giving analyzer tools for all, right? Uh, like I think it's yeah, like because giving a open source analyzer tools, I think we need to hear feedback from silicon vendors. I think it may have some pushback. Yeah.
I know. So that's why there's no easy path here. We are in the domain which is hard, and there's no easy solution because we can't fully open source it like Linux, but we can't make it completely proprietary vendor specific also. Because that will become very difficult for us to implement or deploy in our fleet. So we need some balancing act here. And some trial and error. That's why I'm saying that the whole REST API infrastructure is going to take some time for us to really deploy and see the benefits. Anyway,
I want to just close on the second part of the question that the problem statement that you called. One is the PPR. You also mentioned about the applications and the memory errors when the applications themselves are running. So could you clarify on that part also, meaning memory errors will happen and they do happen, and there is a standard way to report errors, correctable or uncorrectable, that's available today. So what is the new thing that we want as part of this changed, like whatever is the problem statement, right? What is the new thing that we want to do on application triggered memory errors?
Sorry, I was sidetracked. I don't know if I talked about error reporting. We were talking about boot time PPR, right?
Yes, boot time. Yeah. We talked about boot time. You also mentioned about applications creating errors, and they are again have to be locked, right? Like the next time you boot, it will have to be fixed during the PPR. So I wanted to get the second part of it. When the applications have fault, yes, that gets recorded. The next time we boot, it will get fixed, or if PPR works.
You mean on demand? Demand reads based error, right?
Right. Yeah. So I wanted to make sure I didn't miss anything when you said during application there is memory error. If all you meant is the applications could potentially have errors and they're fixed during the PPR, then I'm good, right? I was trying to clarify if there was anything else you meant as part of the application errors.
No, that's it. Runtime, okay. Yeah, runtime error, right?
Yeah, but runtime error, runtime error will just be reported as a normal error, right? Normal memory error.
Yeah, but if you detect a row failure, some entity who's monitoring these runtime errors is also trying to figure it out, is it a row failure? And if it's a row failure, then we need just error correction is not, especially if it's a persistent fault, then just ECC error correction is not sufficient, because now you're exposed to silent error or maybe uncorrected error. Do you understand what I'm saying?
Yeah, but sorry, I didn't fully understand. I understand. Okay, fine. memory errors happen. There can be single bit, double bit errors. That's fine. Today we have schemes for all of them, right? So what is new? So I didn't follow completely.
Nothing new. We do that today, right? PPR we do today.
Right.
Yeah. I was just discussing in this line item, boot time PPR, we are simply discussing about some of the challenges we face in deploying PPR in our fleet in a more platform agnostic way.
Okay.
And
Yeah,
when I say
but this is
implementation,
not runtime though. That's why I want to clarify between the two, right? This is not runtime. This is boot time. So on runtime, we don't. I mean, it's a standard flow. There's nothing. We don't do PPR on any of that stuff.
okay, so maybe there's a gap in our communication here. This
Mm.
boot time PPR, what we're talking is taking a PPR action during boot time. The actual errors could be happening during the boot time itself, and that's causing boot time PPR, or the errors actually happen on the previous run, and during the previous runtime, the determination was done that it's a row failure, and a request for a boot time PPR is made. And now when the machine is booting, that request is fulfilled. So the
Right.
error profile was created during runtime.
Correct.
Okay. So
Right.
that's the runtime. And then next boot is where the boot time PPR is actually taking action.
Okay. Then I follow it. Yeah. That's yeah. Got it.
Yep. Okay. I think we have killed the 1 hour. So I think let's keep discussing, and next meeting we'll reconvene, and everybody, all the other key players are there. I think error injection, and then continue from there.
All right. Thanks. Happy Friday.
Thank you. Yep. Bye.
Bye.